Hello and a very good day to you. My name is Syakirin. Alright, today I'm gonna tell you about lights and waves. Okay, first of all, I'm gonna tell you about optics, which is light. Okay, the nature of light. Okay, lights waves are part of electromagnetic waves or radiation, including X-rays, ultraviolet, infrared rays, and radio waves. Light have certain common properties, which is they travel through space at the speed of light, which is 186,000 miles per second or 300,000 kilometers per second. They also carry energy from one place to another. In free space, electromagnetic waves have the velocity of light. Okay, this is some example from me, as you can see. Alright, light differentiation. In a light spectrum, there are 6 colors can be identified, which is red, orange, yellow, green, blue, and violet, with indigo being difficult to distinguish. When light passes from one medium to another, it is refracted. Dispersion is the separation of white light in diffraction into spectrum colors. Color combinations. Certain objects appear in color when the surface absorbs some frequencies and reflect others. The color will only allow light with the longer wavelength associated by the color itself. Right, reflections. It happens when light changes in direction of a light wave when bounced off a boundary. Okay, there are two laws of reflection. Angle of incidence, which is I, is equal to angle of reflection, which is R. Both rays lies in the same plane, normally at the point of incidence. Okay, it was applied on both curved and flat surface. There are two types of curved surface, as you know, concave and convex. Refractions. It happens when light rays change direction when they move from one medium to another. When they move into a more dense or less dense medium, and respectively slow down or speed up, can impact the direction. Okay, this is it. End of lights. Okay, right now I'm gonna tell you about wave motion and sound. Mechanical wave. As you know, energy travels in two ways, which is particle or by wave. Wave is a disturbance of a medium which transports energy without permanently transporting matter. There are two most common forms of wave, which is transverse wave or longitudinal wave. First of all, transverse wave. It was particles of the medium are displaced in a direction perpendicular to the direction of energy transport. Particles do not move along the wave but oscillate up and down. Okay, that means they do not go left or right, just up and down, right? Okay. Longitudinal wave. It is the particles of the medium are displaced in a direction parallel to energy transport. Alright. Particles do not move down the tube with the wave but oscillate back and forth. Wave is seen as the motion of the compressed region. Okay, you can see compressed region and the rarefaction. Water wave. A combination of both transverse and longitudinal wave. The particle travels in clockwise circle through the water. The radius of circle decreases as the depth of water increases. This means it has both wave, you know. Wave characteristics. There are 6 of 8. There are 8 of it. Alright. First, there are wavelengths. Second, distance between two crests. Third, frequency. Number of wave crests that pass a point every second. Pronoun in hertz or Hz if you write it down. Okay, and then we have amplitude. Head of wave crest above undisturbed position. We have velocity, speed and direction that the wave crest itself is moving. This is the example. If you can see wavelength, amplitude, frequency, and period. interference wave. Interference or superpositions occur at a point where two or more waves meet. Okay, the combination of waves produce larger or smaller waves or even cancel each other out, causing no disturbance at all. There are two common interference waves, which is first constructive interference and destructive interference. Okay, about constructive interference. It happens when two waves having different amplitude are in phase. About destructive, they are when two waves having different amplitude and the second wave is perfectly out of phase with the first, which means they are not same. Okay, waves. Now, this is the example of constructive wave and destructive wave. Alright, standing wave. Okay, another part of wave. Standing or stationary waves occur in wires that are tightly stretched between 2 points. Transverse waves travel to the end and reflected back when the wires are plucked. Alright, a pattern is formed when the waves travel backward and forward along the wire. The pattern characterized by a certain fixed point along the medium which undergo no displacement and called nodes. Alright, that's a very important thing. The midway between every consecutive nodal points are points which undergo maximum displacement and called antinodes. Right, that's the second one. Alright, this is the example of antinodes and nodes. You can see what I mean. Alright, out of wave, we continue to the sound. Alright. Oh, sorry. Sound is energy and is produced when an object vibrates, causing the surrounding air particle to vibrate also. Then it travels through air or other mediums in the form of longitudinal waves. Also can be called acoustic wave, which is a region of high pressure and low pressure. They're known respectively as compression and rarefaction. Earlier I told you. Okay. The region where molecules gathered closely together is known as compression. Yes, and as they move apart from the region of rarefactions, human ears can detect frequency between 20 and 20,000 Hz approximately. Sound speed increase with the increasing of air temperature, which means the higher the temperature, the higher the speed increase. The increase in speed, the sound speed. Sorry. Alright, sound intensity. It is determined by amplitude of the sound wave, which is the wave characteristic. Okay, the higher the amplitude, the higher the sound. Okay, it was measured in hertz but measured in decibels, which is dB if you write it down. Ratio of one sound to another, which means 1 decibels is the smallest change in sound intensity and the human can detect. Alright, frequency. Frequency is the number of vibrations completed per second, which means frequency 1 over time, which is time is second. Okay, measured in hertz. The higher the sound, the higher the pitch. So, sound propagations, transmission and reception of sound. It has three that determine it between source, medium and detector. Range of human can hear 20 to 20,000 Hz, as I told you. Okay, down there you can see compression and rarefaction, the molecule. Okay, Doppler effect. Alright, it was the apparent rise in the pitch or frequency of a sound as its source approaches the hearer, and the decrease in pitch as the source moves away. An example, when the police car come to you, it was squished up and the pitch is higher. When the police car go away from you, the frequency is stretched out and the pitch is lower. Okay, sound vibrations. It causes wave which radiate out from their source at the speed of sound. Right. As you know, the speed of sound is 300,000 km per second. Okay. Aircrafts move less than speed of sound, and the sound will move ahead of the aircraft. Okay. Aircraft fly at the speed of sound produce shock wave. Oh, that's the one. Okay, speed of sound. Alright, interesting. The speed at which the mechanical vibration of sound travel in an elastic medium varies with temperature and altitude. This sound wave at various velocities. Yeah, these are the sound wave. Okay, Mach number. Wow. Airplane speed ratio to the speed of sound in the same atmospheric conditions. Mach number is in the easy way, aircraft sounds per sound of speed. Okay, down there is just the timetable. Resonance. The natural frequency of a given object vibrates naturally or without the external force. Two objects have similar frequency. If one vibrates, the other can move to a destructive force, which is dangerous. Alright, that's the end for me. Okay, thank you for watching. Hope to see you soon.